Hi everyone, it's Chapter 12, Math with Business Apps. This is my Part 5 video. There should only be one video here, I'm hoping. And I'm going to end this chapter with a retirement example that kind of puts a couple of these pieces together so we can really see the power of interest, the power of money. So we're going to have Tony, who is setting up his retirement account. So he is now, say, 20 years old. And he's kind of ahead of the ball game. And he wants to set up his retirement account. And wants to set up his retirement account. And we're going to go through all the pieces. And again, we are simplifying the situation. I'm not going to take interest or inflation into account right now. We're just going to kind of get the idea behind this problem. So his plan is he's going to retire at 65. Okay, I'm going to kind of just abbreviate all this. And he wants to get, so once he turns 65, he wants to make sure to have enough money so that he can get, let's say, $4,000 every month until he's 90. So he's going to kind of guess that he's going to live to age 90. Once he's past 90, this account will be gone, and he'll have to figure out some other form to live off of. So we're going to also assume here that this piece earns, and we'll go 6% compounded monthly. Okay, so this would be his first step, is to kind of decide all these parts. So he has to decide at the age he wants to retire, how much he wants to get every month or every year or whatever. And again, kind of a guess as to how long he's going to live. And we're just guessing on this 6% compound monthly piece. So the first thing we're going to do is calculate that. So if you think about it, at 65, he's going to have this huge chunk of money that's going to pull off these $4,000 payments. Even though that this is in the future, in this situation is a present value problem. So the first thing we're going to do is calculate that present value. Again, present value formula looks like our payment, 1 minus 1 plus I to the negative n all over I. So for this situation, our payment is $4,000. My I, once I get there, is that 6% compounded monthly. My N is going to be that monthly, and here I need to subtract 90 minus 65. Oops, turn it on, 90 minus 65. I believe it's 25. And multiply that by 12, and I get 300. And then all over that 0.06, all over 12. Okay, so this is our present value type piece, so we're going to type all this in. So I've got my $4,000 times parenthesis 1 minus parenthesis 1 plus 0.06 divided by 12. Raise it to the negative 300, close that parenthesis off again, make sure you're on that main line, divided by 0.06 divided by 12. And we need 620,827.46. Okay, so that is the amount he needs right here. All right, so that's going to be the amount. The next thing he needs to do is get to that point, because his employer is not going to give him that piece. So this is then going to be, we need to save for this, or he needs to save for this. Okay, he gets paid every 2 weeks. Let's say he earns a bi-weekly, just to change it up a little bit, paycheck. And we want to know how much should he put away. He deposit if this earns. And a lot of times we can get a pretty decent interest rate if we invest early and let it sit. So I'm going to put 8%. And we will say compounded. And again, it has to match our payment period, so bi-weekly. So now our story turns into we're looking for these little pieces to get to this amount. So that's going right here. So this now turns into a future value. So we have to remember, what is the name of these payments that lead to that future value? That is referred to, again, a sinking fund. All right, so we're going to sink some money into the fund to earn that piece. Sinking fund payment. And you do have a formula sheet, so if you wanted to add these pictures to all of those, that formula sheet to help you out, that might be a good idea. But that future value is going to also show up in this formula, so that might help, because future value is in the future, payments coming before. And we're going to see this I, and this is the one with the positive end. So this is the formula that it looks like there. So in this problem, our future value is at 620,827.46. My interest rate has changed a little bit because we are saving now. So we're not going to be taking money out yet. It is bi-weekly, so divided by 26, parenthesis, double parenthesis 1 plus 0.08 over 26. My N is at 26 times, let's see, he's 20 now, and he's retiring at 65, so that's 45 years. So that is 1170. Okay, so here we go. Type it all in. Clear. I need my 620,827.46 times parenthesis 0.08 divided by 26, close the parenthesis, divided by double parenthesis 1 plus 0.08 divided by 26, close that one off, raise it to 1170, minus 1 again down on the main line, and hit equal. He needs to put roughly $53.97. So just under $54 every couple weeks, and he'll have that piece saved up. So there's a goal for you. You know, if you want to get the situation, start putting away $54. If you're over 20 years old, you'll have to adjust and refigure this out. Okay, let's calculate the interest for this so that we can kind of see the power of interest. Again, remembering the interest is the difference between what goes in and what comes out. So let's do the goes in part. He is sending in $53.97 every 2 weeks for 45 years. So 53.97 times 26 times 45, 63144.9. So just over $63,000. Now, what is he getting out of this whole thing? Some would say it would be that 620, but that's not the case. Okay? he's actually getting more, because remember, that's going to sit there and he's going to pull off of that. So that's what's going in, and we're going to put the coming out. Because what's coming out of this account is $4,000 every month for, what did we say, 25 years. So 4,000 times 12 times 25. 1, 2, 0. I gotta probably 1, 2, 3. So actually, put in some commas. $1.2 million. So let's subtract those. And I have 1,136,855.1. Interest. This problem is going to earn over $1 million in interest. And the reason for that is because, first of all, we do have kind of nice interest rates. Whether we could get those or not is debatable. Second is the money is sitting for a long period of time. He's letting those first payments sit there for 45 years. So that's 45 years of accumulating interest, and interest on top of that interest. Once it turns into this large chunk of money and he starts pulling off of it, you have to remember this first $4,000 payment is probably mostly just the interest earned on that. So this is going to take a while for this to dip down. So he's getting interest on that as well. So that's where we're seeing all this interest build up. I like to show this problem because then we can really see how putting our money away now, early while you're young, can help you in the long run when you get older. I hope you enjoyed these videos. I hope they helped. Have a great day, and I will see you hopefully sometime when you swing by my office. Talk to you later.